Good morning to all those who have joined now. I'm sorry, there is a huge network issue on connecting and disconnecting again and again. At present moment, is this slide visible and am I audible to you people?
Yes, sir.
Okay, thank you. So we were discussing about the execution process, and we have seen that whatever Java file we write, whatever Java program we write, that is called as source file. And when it is compiled, it will be getting converted into this compiler will create one more file. Apart from this Java file, it will create one more file for us with the same file name with the extension of .class. In this file, what it contains is, it contains certain intermediary language code which can be understood by Linux operating system, Java installed on Linux operating system, Java installed on Windows operating system, Java installed on any other operating system, even on mobile based devices. So irrespective of the architecture, this file will contain the details which can be understood by all the Java compilers which are installed on different machines. What actually happens is, in traditional programming, apart from Java, whatever file we write for C program, whatever C program we'll write, it will get compiled into one file which is having some file name .obj extension. This .obj file will be dependent on which operating system you are using. Suppose you are using Windows operating system, that .obj file will be only and only available to be understood by the Windows operating system. While compiling the program in C language in C++, what you did? Alt F9 for compilation and you pressed Control F9 for execution, right? Alt F9 was for compilation. When you pressed it, your C compiler converted it into a file with the extension of that file name .obj, object file. But that object file can be understood only by the specific operating system on which that particular file was compiled. Now, if you copy that particular .obj, suppose you have executed on Windows operating system, you pressed Alt F9 on Windows operating system, you copy the .obj onto Linux operating system and try to press Control F9 for execution, it will not work. But in case of Java, once this file is converted, once the source file, Java source file, whatever program we have written, .java file is compiled and converted into .class file, you copy this .class file and paste it into any operating system related Java compiler. There you can execute it without recompilation. This is the benefit of Java language. So once you have written the Java program, you just need to have your .class file, paste it into multiple operating systems, and there it will work fine without any problems. Is it clear? So what is the benefit behind it? The first benefit is we need not write our program and compile it again and again on multiple operating systems. Once we write and compile our program on one operating system, irrespective of what the client is, we as a developer will develop the program on behalf of a client. Client will request for us to make a program. We'll develop it for him or her, and we'll just push it down to them. We'll just send them that particular .class file. Now they will execute the .class file on their particular systems. Tomorrow, if the client is saying that I have changed my operating system, you give me one new code, you need not sit and write and compile again. The same program which you have sent will work fine. Whereas in case of C language, it will not work. C and C++. You need to recompile it on that particular operating system specifically. Now, once this dot class file is created, how the execution process goes on. This is the part of compilation. Execution goes. It is very similar to alt process. Okay. Now, for execution, Java has got one specific component called as Java Runtime Environment (JRE). Java Runtime Environment. This component is responsible for executing the class file. Is responsible for executing the dot class file. Okay, I'm again repeating. There are two components. One is compiler component, another is runtime component, execution component. This compilation component will convert your dot class file into dot Java file into dot class file. Its main purpose is to take your source code, which is written in as English language, and convert it into dot class file, and this will contain a code written in some intermediary language. Why I'm saying intermediary means it will contain certain words with regard to English language. It will contain certain words which can be understood only by the computer. We don't know what those words are. Okay, so it is intermediary code. And this dot class file is called as bytecode. Java runtime component, runtime environment component, it is responsible to take dot class file and get it converted into dot exe file. What it will do, it will take the dot class file, convert it into dot exe file. Now, while converting the dot class file into dot exe file, what it does is it will first have a look on any header files being used in your program. If there are any header files being used in your program, it will try to load that particular header files. Your header files are called as classes and packages. Header files will be called as classes and packages. So it will load those classes and packages which are mentioned in the program, and to load it, there is a special component in Java runtime environment, one subcomponent called as class loader. It will load those particular extra header files inside your program. Again, I am saying those header files will be called as packages in Java programming. Once those related code is also included in our program, this part will be sent to Java virtual machine. Java virtual machine will try to make sure that whatever program you have written, it is being interpreted line by line, it is being checked line by line, and for easy computation, it will have a just-in compiler also for fast execution. What will happen is it will go through line by line, one after the other, and once that particular program is over, finished, line by line, it will have a recap of whole scenario once again. So that just-in compiler will go for a quick compilation part to enhance the timing. Okay, but this Java virtual machine will interact with the operating system. It will not allow the programs to interact with the operating system. Whatever program we have written, that program cannot directly interact with the operating system. It should get interacted through the Java virtual machines component called as runtime system. This runtime system will verify whether the operating system files or any resources that are being accessed, are they being accessed with the safety measures being followed or not. If there is a security issue coming in between, then this runtime system component of your Java virtual machine will not allow your program, which is being interpreted here, to interact with the operating system. So this pink color box acts like we see it as a sandbox, where you will first test whether that particular program is going to work or not. Once that particular program is working fine in that particular box, then it can interact with the operating system. Otherwise, it cannot. So by introducing the Java virtual machine, Java compilers have enhanced the security issues and improved them to a much detailed extension. Hello, good morning, bhai. Yes, ma'am. 11:30. मैं कॉल करता हूँ आपको 10 o'clock को कॉल करता हूँ नहीं नहीं ऊपर क्लास में हूँ ओके चलो चलो so the same process I have kept here in a different picture whichever you wish you can just learn from that it is your wish whichever you adopt you can adopt here also the same thing has been depicted here. The Java program which we write, we'll write it in a text editor. For simplicity, I'll follow Notepad file here for text editor. There are various other text editors available. Many of them are very sophisticated. They are having built-in components which we can use for our easy programming. And those are called as IDEs, Integrated Development Environments. Those IDEs can be used for writing our Java program. So whatever may be the text editor, what is the simple thing we are doing here is we are writing our Java source file. That Java source file will be given for the Java compiler to convert it into .class, which we have seen in the which we have seen in this particular part. Okay. Now this particular bytecode will be given for the class loader to include all the header files. Again, I am saying header files will be called as packages here. So all the packages will be loaded by the class loader. Packages are a collection of classes and interfaces. So whatever classes are being mentioned over there, those classes will be loaded by the class loader component. And again, the bytecode will be verified and interpreted, whether those classes are matching or not, whether all the functionalities are being verified. All those verifications will be done. Parameters are matching or not, and interpreted. But all this part will be done by whom? Java Virtual Machine. Okay, this Java Virtual Machine is part of JRE. Okay, and what I have listed here, JRE, Java Applet Viewer, IE, Netscape Navigator, all these are sub tools available in Java Virtual Machine. This Java Virtual Machine will be the one which will interact with your operating system. Do remember, your Java program cannot directly interact with your operating system. If any illicit code is written, this bytecode verifier and Java Virtual Machine will stop the execution here itself. They will not allow your illicit program to interact with the operating system. That's why it is almost impossible to write any type of virus program using Java language. So even viruses, whatever viruses are there which are affecting system, those are also some sort of programs. Those are illicit programs which will corrupt our operating system. If the program is to be developed, virus program, that program cannot be developed using Java language, because Java language has got sandbox testing here using Java Virtual Machine, which will halt that process. So what is JDK installation process we have seen? I'm not going for that particular task again. We will come back for execution practically when we do it. So what is our first Java program going to contain? What is the first line that we have to write? We have to write, do remember, whatever you are writing in Java, you are going to put it in terms of classes and objects. So first thing that you have to do is you have to define your own class. So I am taking a name to my class called as hello. You can write anything over there. Hello or ABC or XYZ, something like that. But to tell the compiler that this hello is actually a class, I'm writing a class keyword before it. And to make it available for execution for general purpose, I'm making the security issue as public. So I'm not applying any locking mechanism to it. Okay, I'm keeping my code plain and simple. So the first thing that you have to do is you have to define your class. So how do you define your class? You will write class keyword and then you will mention that particular name of the class, your own given name. So now after that, your class will begin with a curly brace. As that of your C++ programming, your class will become stand with a curly brace. Now once you have written the curly brace, the thing that you wanted to do in your program is the logic. So my logic is to print on the screen hello world. welcoming message on the screen. So to print that particular welcoming message or hello world to the user, hello world message to the user, I have to make use of some function. And the function which is responsible for starting of execution of your program is the main function. So to write the main function in C language and C++, it was very simple. We had just written void main and opening and closing parenthesis, that's all. Sometimes you have written only main, but that return type will become integer there. That's why we used to write void main and we used to write our programming logic there. Here in Java, it is little more enhanced. Here you will mention what is the function name, main, as usual as that of your C and C++. You will mention what is the return type. You are telling that you are not going to return any value back to the caller. You are mentioning that this function can be called without creating any object by using a keyword called as static. And since it has to be accessed by the compiler, which is outside of our class, I am mentioning it as public nature. Okay, so what is the syntax of our void main in Java? Public static void main. Do remember these 4 words. In every program, you have to write this particular 4 words for your void main function. And within the parenthesis, you are going to pass arguments. These arguments are the set of code or set of parameters which you will pass while your program is getting compiled. Okay, so we will call them as command line arguments. We will call them as command line arguments. So we are starting our void main function. So as usual in C and C++, here the void main will start with a curly brace, and then we'll write the message which we wanted to put onto the screen, displayed on the screen. We wanted to put a message to the user back that hello world. So whatever message you wanted to keep, you have to display it through a function called as println. The name of the function which is going to print that particular message is println. This is same as that of your C++. In C, not in C++, you have in C language. Printf was there. Just similar to printf, we have got here println. ln is for new line character. Fine. This print function is present in an object called as out. Whatever output devices are there, those output devices are represented using out object. Those output devices, whether monitor or a printer or something like that, are a part of our system only, right? So system, whatever system is a desktop, laptop, or whatever displaying device is there, that system is represented through a class called as system. What is the name of the class? System. So how do we call this println function, which is a predefined function? We'll write system dot out dot println. System is the device, dot out is the output component of the device, and println is the function which will display the message which we are passing within the double quotations. So our logic is over, our target of the program is over. We'll close the void main and we'll close our class definition. Now, what is the process of compilation? How do we compile it? To compile it, we will not use the C compiler technique, Alt F9 and Control F9. We have to open our command prompt, black screen, and we have to type the code over there. The command that is meant for making a call to the compiler, executing your compiler, is javac. So whatever directory you are working in, you have to type javac for calling or invoking your Java compiler. Into that compiler, you have to pass the file which you want to compile. And the file which is there for me, the code which I have written, I have saved that file with a file name of hello.java. Now one more point here. Why I am using hello.java? Why not abcd.java? Why not f1.java? It's because in Java programming, it is compulsory for you to save the file with the same class name which is going to contain the main function. So the class which is going to contain the main function in my program is hello. That's why I'm writing hello.java. Use any random naming for your file name. You have to keep only and only that name, which is the name for the class which is containing your main function. This class which is containing the main function is called as the main class. So for the file name, you have to use the same name as that of your main class. Okay, do remember this thing. That's why I have written hello.java. So that was for the compilation. Now for making a call to the Java runtime environment for execution purpose, you have to just write Java. You have to write Java. This Java keyword or command will call Java runtime environment to execute this particular file. Do remember we are passing hello only here. We are not giving the extension here. Okay, not even hello.class. You will just write hello here. What happened? At this compilation part, hello.java has been taken as an input and one more file has been generated which is called as hello.class. Fine. In case of compilation, we have given hello.java as input and one new file was created, hello.class. For execution, Java runtime environment will take hello.class and convert it into hello.c. But here, for the command that we have to write, there is a small point to be noted. In case of execution, Java runtime environment will not take any file extensions over there. You will not even write .class there. Okay, this is a specification from Java which you have to follow. So you have to write the keyword Java space hello. That's all. Okay, and it will execute your program if it is perfect, and it will display the hello world message back to the user. Whatever you have typed in the double quotations will get displayed back onto the user. So this is the simplest part of our program. Whatever I have written in the green line here is the comment which will help the new learner, new person who has seen this program to get to know what is the program meant for, what are the lines meant for, and it will be easy for us to debug our code, to go through our code very easily if the comments are present. If the comments are not present, it will become very difficult for a new person to go through our code. We as a developer, we can go through that code, and since we have written that particular code, we will have the concept in our mind why we have written that particular line. But as a new person, they will not be able to understand it. So how many different types of comments are there? We will try to see all those things in the next coming on sessions. Now, yesterday, day before yesterday, we had a look on to applets also. So in simplest term, applet is a Java program which will be written and saved onto server, and from server it will get downloaded onto client and it will get executed on the client machine. Simple thing. Java's applets are nothing but simple Java programs which are written and saved onto servers. They will get downloaded onto client machines and will get executed on the client machines rather than getting executed on the servers. So the benefit in that one is server's resources will not be wasted. Normally what will happen is through a web application or something like that, we will make a request for the server to execute some part of program and give the result back to the client. So suppose if 10-15 persons are requesting, it's fine for the machine. Even servers are computers, right? It is fine for them. Suppose 1 billion or 1 trillion people are accessing at a given moment of time, and all those requests are to be executed on server and the result is to be sent back to them. Will it be easy for the server to execute all those requests? No. Instead, the server will send the piece of code which is to be executed back to the client machine if they are able to execute it, and that particular code will get executed on client machine and server will relax. So even if 1 trillion request is coming, the code will be sent to 1 trillion machines which are individual, and that machine will execute only that piece of code. Okay. So instead of executing 1 trillion programs, now it will become one program per system to be executed. Whoever makes a request, they will execute that one. So this is the simplest logic of Java applets. So in case of Java applets, what we have to write is we have to include one package which is defining the applets functionality. That package or the header file which is containing the applet functionality is called as AWT, Abstract Window Tool Kit. AWT, Abstract Window Tool Kit. This AWT is the package name, which is, I'm again telling, package is a collection of classes, multiple different classes which are interrelated and interfaces which are related together. That collection itself we are including. And in this collection, there is a class which has defined the functionalities of applets called as applet. The name of the class itself is applet. Okay, so all the Java packages will be included in a simple package called as Java. So Java is the uppermost package, and the sub packages are AWT, IO, and different packages are there. We'll see all those package names once we are going through the packages. For the simplicity, again I'm telling, whatever Java applet functionality is defined, it has been defined in a package called as AWT. And this package is present in an upper package called as Java. You can just imagine them as folders. You have first folder Java. Within that folder, you have got another folder called as AWT. Like AWT, we have got multiple other folders present in Java folder. Okay, so this becomes your main folder. Within that folder, you have got multiple subfolders. And this asterisk represent whatever is present in the AWT to be included. This asterisk is meant for representing all those things which are present in this particular folder, AWT folder. So what will be the things present in that folder? They will contain the classes and the interfaces. Interfaces are very similar to classes. I will explain you when we can come across the fourth unit. Okay, what are interfaces and why do we use it? I will explain it at that particular time. So whatever classes and interfaces are there, we will include them by using a keyword called as import. In your C and C++, you had a keyword called as #include. Those keywords #include were called as preprocessor directives, and those preprocessor directives were responsible for including the stdio.h or iostream.h functionalities into your program. Here we have got import. We are importing that particular functionality back into our program, right? So import space java.awt.asterisk. This is the first line that you have to write in your applet program. Second line is, like AWT, we have got one another package called as applet. Got one specific package called as applet. This applet folder or package will contain all the classes which are pertaining to applet, which have been predefined by the Java developers. So I am telling the compiler to include all those classes and interfaces which are present in applet folder and which is present in the Java folder, and import it. Okay. So once those are imported, our next part is to define the class. Fine. So we are going to define a class called as simple. We have given the name of the class as simple. But here, I don't want to make it as a normal class. I want to make it as a applet class. Applet class will be a graphical user interface. It will contain certain buttons. It will contain certain text boxes. It will contain certain things which we can click on and perform some action. But in case of normal Java programming, it will contain only black and white screen where you have to type the command and you have to execute the program, just like your C programming. Here, you are creating a class called as simple. But since you wanted to make this class as applet, you are extending it to applet category. So what you are doing, you are using a keyword called as extends, and you are extending a predefined class which is already defined in the applet folder. which is already defined in the applet folder. Don't get confused with the naming of the class and the folder. This is the package name. Do remember, all the package names will be always coming with a smaller case. They will never be coming in the uppercase. They will be always lowercase. But in case of class name, the first letter of every class will be a capital letter. That's why if you recollect back, hello that we have written, simple that we have written, our own given names are also containing the first letter as a capital letter. Okay, so we are creating a class and we are extending the applets functionality into it. So what is the logic here? In case of normal Java program, we used to write void main function to write our logic. But here we'll use a function called as paint. It is very similar to that of your main function. Instead of main, you will write paint function here. So you will use a keyword called as paint. This is the name of the function. It doesn't return anything back to the caller, void, and it is of public nature. But since it is a graphical user interface, since you are able to click on certain buttons and you are able to see a form, you will use a class called as graphics, and you will create an object of it called as G. Fine. So within this graphics class, you have got a function called as drawString. Just like we have seen println function for the message on the screen, we have got drawString, which is similar to println, and whatever is to be written on the screen, we'll just pass it into double quotations. But here is the problem. You will not just pass what is to be written on the screen, you will also pass at what coordinate locations you want that particular message or the string to be displayed. So I'm telling, display it at 20 pixels on x-axis, 20 pixels on y-axis. Our axis starts at the top left corner of our page. It will be like 0, 0 at the top left corner, then goes on in the x-axis continuously, then comes down on the y-axis continuously. So 20, 20 can be 20 pixels on the x, 20 pixels down in the y. So it will display the message somewhere around here. So that's the whole thing that we have to do in Java applet program. But do remember, applet programs are Java programs. They had to be sent through some HTML program to the client machine. So to send them through HTML programs to client machines, we'll write the HTML code. And to include the Java applet program in our HTML code, we have got a special tag called as applet tag. This applet tag will contain an attribute called as code. Whatever I have written in capital letters are the keywords. Those are reserved words. Okay. It will contain an attribute called as code, wherein we have to specify, after compilation of this particular file, the location of that .class file. Once we compile this Java program normally through JavaC, then simple.java, it will get converted into simple.applet, right? That simple.applet's path or the file location should be specified in the code attribute. And we have to mention in which width and height we have to display this particular program result. Okay, so this result of the program will be a frame containing some buttons and so forth, and we have to display that particular outputs, width and height, how much we want to have. Okay, that's all in the HTML we have to write. Simple. Now to execute this one, this is not a normal one. It will get executed on the client machine, right? So on the client machine, I cannot ask the client to type JavaC then filename.java. It will be wrong. So there are two ways for compilation. Is you execute the HTML file on the browser. As a normal website execution, you will go for HTML file to be accessed through your web browser. And the web browser is capable enough to execute your Java applet programs. This is a normal process, which I have listed in the second part. But if you are a developer and you want to just go through for the errors checkings, you are just making a trial and execution errors or error checking mechanism, then you have got, instead of web browsers, you have got a specialized tool for quick overview execution process checking called as applet viewer. You will use